In this video you will learn how to use geometry nodes to make procedural vines. And the beauty of it is that you can cover anything with those vines, no matter the geometry, no matter the topology, nothing. It just works. There are a few stages to this project. First, we're gonna learn how repeat zone is very similar to simulation zone and how they are different. Second, we're gonna use it to extrude along the surface of the object. Then we're gonna use a lot of capture attributes and sample near surface nodes. And then we will learn how to use captured information to offset the vines to make them look natural. And then we will learn how to use attributes to get the information needed to create our own UV texture from curves. And using that, we will make the materials. We're gonna use Suzanne because it's an interesting shape, use geometry nodes, add our repeat zone, and distribute points on faces. And this is how many separate vines we'll have. One vine from each point. Extrude mesh, and to make it work, convert points to vertices. It extrudes outwards. Use noise to give the extrusion some direction and make it weaker. Now stop. Don't do anything, and look at this. After I added just 15 iterations, my Blender froze and crashed. But it doesn't look like we had much geometry. So why did it crash? It's because with this setup, each iteration, each existing point gets extruded. What does it mean? It means that even though we don't see much, the amount of points doubles each iteration. So the load grows exponentially, and not a single computer in the world can handle that. To fix it, connect top into the output and plug that new connection into the selection input. That will make it so that only the ends of the curves get extruded, and it becomes a lot more manageable. Bring iterations up to 256 and join geometry to see the original. Each time we go another iteration is like in simulation zone going forward one frame. Basically the same, but I think there are some differences. I like the repeat zone because you don't have to wait for it to simulate and it's just instantly ready. So each time we iterate, we sample nearest surface position from the original object and set position and connect it into position input and connect top into selection. That looks nice, but all of the lines feel like they are stuck together and deform all the same. Let's give them some random deformation. If you use noise texture in simulation zone, you'd connect scene time into W to move the noise, but here it will just move the whole thing. To get a similar effect, we are gonna use iteration number as our scene time. Noise is not quite uniform. Vectors are XYZ values that we preview as RGB. But the problem with noise texture is that noise value is not just direction, but also some strength. Some of the values are smaller and some are bigger. We can turn that noise into just direction values, and all of those values will be at strength 1. To do that, just add normalize node. That will prevent those sharp turns in geometry that happen because of weak vectors setting the direction of the extrusion. But when all of the vectors have the same strength, it doesn't allow for sharp turns, giving us smoother geometry. We have already sampled position. Now we are going to sample normal. We can use that vector with set position to expand the vines outwards. Add set position and offset it so that the vines are a little off the surface, so that it doesn't break when we extrude it. And then after the repeat zone, compensate for it with another set position node in the opposite direction. Capture attribute, index. That capture attribute output will give us an index per vine. We can use it, for example, to get random value per vine. Add it here, and the more random and bigger those values are, the more different offset each vine will have on its noise. Without it, we are kind of using the same noise for each vine. Or just multiply it by 8, so that the bigger index value is, the bigger offset is. And that covers everything nicely. I don't like that this wire runs across all of the nodes, so I just duplicate the group input and connect it at the end. Mesh to curve to mesh, curve circle. Spline parameter and float curve to make it thinner at start and the end of the curve. You can see that the steps are a little messy and different for each curve, and with resample curve, they get the same length. Maybe for now bring the value up so that it's easier to calculate. Let's get some random offset to move the vines away from the surface. We are gonna use another set position in normal direction, but to get the randomness, we'll use a different noise texture. Connect the sample nearest surface normal node into another scale. Set it to like 0.22, add another scale and connect noise into it. Adjust the noise and connect some of the index randomness into W input. Map range, and to make it so that vines don't go under the surface, set to mean value to 0.2. Noise values range was between 0 and 1 and became between 0.2 and 1. If we preview spline parameter, each curve starts at 0 and ends at 1. We'll multiply length by factor so that longer curves have higher maximum values. Capture attribute, maybe multiply it by like 4, that's gonna be our U in UV. Now to find V. If we capture attribute factor here, we can see that circumference starts at 0 and gets to 1 as we go around the full circle. That's our V. Store named attribute UV. You have to save UV maps in face corner domain. Now if we connect them into combine XYZ into X and Y and connect them here and set material, we can preview the UV map in the material. Attribute UV. Add noise texture to see how it works. Multiply everything by 1 and X by a lot more until the texture looks right and not stretched. It depends on the length of your curve. Adjust some of the noise values. You can use math add node to control the seed of the offset. That looks right. Maybe you can animate it with this value. Capture another attribute, position, and use that captured position as vector. That way the texture coordinate vector is set at the beginning and all of the further extrusions use noise in the same position. This one is not a big difference, but a good tool to have in your toolkit. Add another set position. All of the vines are way too smooth, so noise texture, normal direction, scale, finally without sample nearest surface. Scale it down, adjust the radius. We are almost done with the geometry nodes, so I'll bring this value up to make those faces more square. And it's almost it for the vines. Model the very basic leaf, just use a plane, rename it to leaf, scale, extrude, scale until it looks right. Try to get an organic shape. Duplicate, extrude to get the stem separate, extrude the stem and the leaf. Ctrl 2 to subdivide it. Add some loop cuts and deform it a bit to get more natural shape. Apply subdivision. Make sure that the stem is visible. Distribute points on faces. Bring up the density. Instance on points, instance our leaf. Random value to get the scale. Just rotation is not quite right. Use align rotation to vector. And now if we join everything together, that looks pretty good. Random value into Z between -pi and pi. That will get the leaf's random rotation around this axis. This is it for the geometry. For the materials, I used this texture from Polyheaven. Link is in the description. In materials, select principal BSDF, Ctrl-Shift-T and find where you saved the textures. Give our base object some different material. Default UV doesn't work, so we connect the UV that we made. Adjust the multiply values until it looks fine. Add subtle HDRI, add background plane and the lights. That warm light really adds some mood to the image. Give leaves the separate material and just make them green. The rest can be pretty much the same. Probably use the default UV map. And after everything, we get this. Feel free to experiment, apply it to different objects, experiment with noise and the whole setup. And I'll see you in the next video.